Okay, so in topic 4, we've made a good start at developing a mathematical system based on assumptions. So remember, those are called postulates. They're statements that we accept to be true, we believe to be true, and we accept them to be true. Theorems are statements that we have proven to be true. So we'll continue to build postulates and theorems throughout the course. You want to make sure that you stay on top of learning those and that you don't get behind, because you can get behind very quickly. We do want you to know that the first person that recognized this system of math is called Euclid. His last name is Euclid. He's known as the father of geometry. And so if you want to sound really smart when people ask you what math you are taking, you can say, I take Euclidean geometry, because that's really what we are learning, is we are learning a specific type of geometry from Euclid's work. There are other branches of geometry that we will not get into. There's spherical and hyperbolic and just all different kinds of geometry, but we learn Euclidean. All right, so let's summarize what we've learned so far in topic 4. So remember, we started off in topic 1 learning about inductive reasoning. That's always based on observations you've made, and you can write conjectures based on those observations. So a conjecture is something you believe to be true based on your observations, but remember, it could be false. So if you find one example where it doesn't work, then it would be proven to be false. If it is accepted to be true without a proof, then we can make a conjecture and it's called a postulate. If you prove a conjecture, it is called a theorem. So conjectures could be true or false. If they're false, you definitely would not use them in a proof. If we accept them, something is it's a statement that we accept to be true without a proof, then we call it a postulate. If we can actually prove it in a proof, then we call it a theorem. So we developed 2 postulates in this topic, and those are the segment addition postulate and the angle addition postulate. So remember, anytime you hear addition postulate, I just want you to think the parts add up to be the whole. And so both of these mean exactly the same thing. It's just one is dealing with segments and one is dealing with angles. So in the segment AB, its parts are AZ and ZB. And so the segment addition postulate simply says that the distance from A to Z plus the distance from Z to B equals the whole distance from A to B. The angle addition postulate, our parts are these smaller angles, so we would say the measure of angle AXB, that small angle, plus the measure of angle BXD, that small angle, add together to get the whole angle AXD. So the parts add up to be the whole. We reviewed the properties of equality that you used in algebra, and so remember, the properties of equality, the addition, subtraction, multiplication, and division properties, simply say as long as you do the same thing to both sides of an equation, you're you're keeping the equality of the statement. So if you add C to both sides, you're keeping the equality between A equaling B. If you subtract the same thing from both sides, if you multiply both sides by the same number, or you divide both sides by the same number, you're maintaining equality. The substitution property says if you know 2 things are equal, then you can replace one with the other anywhere in an equation. The reflexive property simply states that something is equal to itself. The symmetric property allows you to flip-flop an equality. So if you know A equals B, then B equals A. And the transitive property says if you know A equals B and B equals C, then since both of these things both equal B, they have to equal each other. So A equals C. Remember, once a conjecture has been proven, we call it a theorem. And we have learned several theorems in topic 4. One is the linear pair theorem. Remember, by definition, a linear pair is 2 adjacent angles. That just means they're next door to each other and share a side. They're 2 adjacent angles that form a straight angle together. And a straight angle is simply a line. So that's where we get the word linear. So linear pair just means 2 angles that make a line together. The linear pair theorem states that they are supplementary. So the linear pair theorem says 2 angles of a linear pair are supplementary. Now remember, we can take that a step farther. Since we know what supplementary means, we can use the definition of supplementary to say that that means the 2 angles, their measures add to be 180 degrees. The common segment theorem is simply called that because you have a segment in common. So if we look at segments AC and BD, they have this segment B to C in common. So if we know AC and BD are equal, since they have the BC part in common, that would mean these smaller parts AB and CD are equal. The converse of that just simply switches that and says if you know the small parts are equal, then those bigger parts A to C and B to D are equal. The common angle theorem is exactly the same thing, so it's just using angles instead of segments. The vertical angle theorem, remember if you have two lines intersecting, then you are forming two pairs of vertical angles. By definition, vertical angles are just the non-adjacent angles that are formed by intersecting lines. So these two angles are adjacent, they are not vertical. These two angles are non-adjacent, they are the vertical angles. So in other words, they're the angles that are opposite each other. Now the vertical angle theorem gives me a relationship about the angles. It says that the vertical angles must have the same measure. So in other words, the vertical angles are congruent. That's what the vertical angle theorem states. Finally, we've learned many definitions in this topic as well. So remember, by definition, a midpoint. A point is a midpoint if it separates the segment into two congruent parts. An angle bisector. An angle bisector is an angle bisector if it separates an angle into two congruent parts. The theorems, the midpoint theorem and the angle bisector theorem, says if you have a midpoint, then each section is equal to half of the whole. So if this is a midpoint, then this distance from x to m is half of that whole distance from x to y. And the angle bisector is similar to that. If you have an angle bisector, then each one of these small angles is half of the whole angle. That's what the theorem states. So when you are proving a statement, remember you're using deductive reasoning. So when you put all those true statements together and link them together to make a conclusion, you're doing a proof. And we looked at two different types of proofs in this topic. We looked at a flowchart proof and a two-column proof. So remember, there are four things that we'll use as our reason. So in the reason column of a proof, we'll use definitions, we will use those algebraic properties, we will use postulates, and we will use theorems. We will never use conjectures because remember, conjectures could be false. So what's the difference between a definition, postulate, and theorem? Remember, a definition just recognizes something for what it is. So by definition, I can recognize a right angle when it's 90 degrees. By definition, I can recognize vertical angles when they're the non-adjacent angles formed by intersecting lines. The postulates and the theorems give me the relationships. So once I know I have vertical angles, the theorem tells me that they're congruent to each other. So once I know I have a linear pair by definition, I know that the linear pair are supplementary by the theorem. So the definition's just recognizing something for what it is, and the postulate and the theorems give me relationships about those things. All right, your assignment is 4.5.